Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam, and other exams related to physical science. Okay, so this is the lecture number 8 of thermodynamics and statistical mechanics. Okay, in which I will discuss thermodynamic potential, Maxwell relations. Okay, and Clausius Clapeyron uh, equation, and also phase transition, guys. Okay. Okay, so guys, also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also, guys, share with your friends uh, so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. So thermodynamic potential, guys. Okay, thermodynamic potentials. Thermodynamic potential. Okay, thermodynamic potential. So here I'm going to tell you the trick so that this is important for you to memorize these thermodynamic potentials. Okay, this one. Okay, so here P plus PV in downward. Okay, minus TS in this side. Okay, minus TS, and this is UF and this is HG. Okay, so you need to note down this one. This is in this side, this is minus TS, and in down toward plus PV. Okay, UF HG. Okay, you can memorize it anyway. So I have memorized it like this. Uttarakhand, there are a lot of forests, right? So Uttarakhand forest and Haryana, Gurgaon. Okay, so means Haryana, Gurgaon is city of Haryana, right? So Uttarakhand forest and Gurgaon, Haryana, Gurgaon. Okay, so you can remember in any way, right? So this is the one. So now what we are going to find, first we'll find like this. Okay, so we'll find FG in this side. Okay, so F is going to be, F means U minus TS. F we are getting, right? FU minus TS in horizontal side, right? F equal to U minus TS. Similarly, we'll find G. G is going to be this H minus TS. H minus TS. Okay. And now in downward side, H, we'll find H. H equal to this U plus PV, U plus PV, and then G. G is going to be this F plus PV, F plus PV. Okay. Or GF value we have this, right? So G is going to be F value U minus TS plus PV. Or we can write this. Or we can write uh, U plus PV minus TS. Okay, so these things you must know, guys. So then you can easily get thermodynamic potentials. Okay, so this is called this is Gibbs free energy. This is enthalpy. This is Helmholtz free energy. Okay, and this is Gibbs free energy. Okay, this is this internal energy. Okay, so this thing you can easily note, so you can easily know this if you know this trick. Okay, this is a trick, guys. Okay, trick for memorizing this. Okay, just simple. You have to make box, and you need to divide into 4 parts: UF Uttarakhand forest and Haryana Gurgaon, right? And then minus TS plus PV. Okay, so you will get a value F and G in horizontal side, right? Then H and G in down that vertical downward side, right? So H equal to U plus PV, H equal to this. and here G value is this, F value will put from here, so this is very important one, this point, right? You need to know. Okay, well, so now we'll find these thermodynamic potential one by one. The first is okay guys, let me check whether I'm audible or not, then I'll proceed further. Okay, downwards, right? So yes, I'm audible, so I'll proceed further. Okay, okay. Okay, so here internal energy. Internal energy, okay. Internal energy, this is a function of this internal energy is U, which is function of SV, right? So here we know the formula by first law of thermodynamics, U equal to TdS minus PdV, because we know TdS equal to du plus PdV, right? So it means du is going to be TdS minus PdV. Okay. So from here, this we know. So from here, first case, if S equal to constant, if S equal to constant, entropy is constant, implies ds is going to be 0. In this case, this uh, P is going to be minus del U over del V at constant S. Second case, if this V equal to constant, implies this delta V, dV is going to be 0, right? Implies dV is going to be 0. So in that case, uh, in that case, the value of T is going to be del U over del S at constant volume. Okay, this is the internal energy. Second one, second is enthalpy. Enthalpy, enthalpy. Enthalpy. So enthalpy means enthalpy is H, okay, and that is called heat energy. Heat energy. Heat energy, okay. So here the enthalpy is total net function of the system, okay. Total net function, total net function of the system, okay. Total net function of the system, okay. So H is we know here H equal to U plus PV. I have already told you this trick, right? H equal to U plus PV, right? This you should know this thing, okay. Then you can easily get those thermodynamic potentials, I mean those equations, okay. So H equal to U plus PV, this one will directly write H equal to U plus PV. So it means we'll differentiate it. DH is going to be du plus PdV plus VdP, right? So now DH is going, now du value we know, right? That is TdS minus PdV. This is plus PdV plus VdP. So this going to be cancelled, right? So DH is going to be TdS minus VdP. TdS minus VdP. Okay, this is important one. This is the change in enthalpy, important one. So from here you can get this one. From here you can get T. T is going to be directly, T is going to be del H upon del S, right? at constant P. Constant P means this is 0, so value of P is going to be del H upon del S. And similarly, value of V is going to be minus del H upon del P at constant S. Have you made any mistake? This is plus, guys. Yes, this is plus because this plus, right? So this sign is plus. So V equal to del H upon del P at constant S. Okay. Okay. Next is next is this Helmholtz free energy, right? Third, Helmholtz Helm Helmholtz free energy. Helmholtz free energy. Okay, Helmholtz free energy. So this is that we denote it by F or A, which is function of Vt. Okay, so this is thermodynamic potential at constant forces. Thermodynamic potential. This is thermodynamic potential. Okay, at constant volume. At constant volume. So Helmholtz free energy is thermodynamic potential at constant volume. Okay. So here we know value, right? I have told you this trick. This one Helmholtz energy, that is F equal to this U minus Ts, right? So you'll write F equal to U minus Ts. This. So this is the best way of memorizing learning the thermodynamic potential. Okay. So this is going to be, so this value is going to be that F equal to U minus Ts, right? U minus Ts. So U minus Ts, now del F change in Helmholtz energy is going to be del U minus T ds minus S dt. Now del U value we know, right? dF is going to del U value we know, T ds minus P dV. T ds minus P dV minus T ds minus T ds minus S dt. Okay, so TDS is going to be cancelled. So dF change in Helmholtz free energy is going to be minus PdV minus SdT. Minus PdV minus SdT. Okay, this is important result for Helmholtz, change in Helmholtz free energy, right? So from here we can find this one. We can find value of P. Value of P is going to be minus del F over del T at constant P. Okay, because this will be constant V means this will be 0, then value of S is going to be del F upon del T at constant P. Second value of S is going to be minus del F upon this is the value of P. This is value of S, guys. Value of S. Value of S is This one, value of S is going to be del F over del T at constant V, right? And similarly, the value of P is going to be minus del F over del V at constant T. Del F over del V del T at del F over del V at constant T. Okay, this one. Next, guys. Next is Maxwell relation, guys. These are very important relations. Okay, Maxwell's relation. Maxwell relation. Okay, Maxwell's relation. So Maxwell relations are very important. I'll tell you the trick. Okay, by trick you can easily get it. Okay, so I'll write the equation first. Okay, equations first is del P over del T at constant P, that is going to be equal to plus del S upon del V at constant T. Second is del P over del S at constant P, that is going to be minus del S over del V at constant S. Third, del T over del P at constant S, that is going to be minus del V upon del S at constant minus del V over del S at constant T. And the fourth one is del S over del P at constant T is going to be plus del V over del T at constant P. Okay, so these are the Maxwell relations, guys. Now I'll tell you the trick how to memorize it. Okay. Okay. So we'll make up 4 boxes, guys. Okay, very simple, 4 boxes. These are 4 boxes. First box you need to note down. Okay, first box this will be PSTV. That's what you need to note down. You need to remember. Okay, box PSTV. Okay. Okay, so this is PSTV. You need to memorize it. That's all. PSTV. Okay, PSTV. And this also you need to this one, right? Okay, and order should be the same, guys. Okay, there shouldn't be any change of order, then it will not work. Okay, so this PSTV. Now what we are going to do, P is there, right? We'll change the P position forward, one forward. So P is going to be here, then S will be from here, it will be here, and then T will be, then V will be here, and the T will be this position. Similarly, now this P position again will change one forward, right? So P will be here, right? P will be here means S is going to be here, B is going to be here, and T is going to be here. Now P position will take here, right? So P is here, then S is here, B is here, and T is here. Okay, this one, simple. So now you understand this, very simple. Del P over del T, the first del P over del T at constant V in crosswise in down, right? Del P upon this one. Del P over del T at constant V. This is del S over del V at constant T. Similarly here, this one, del T over del V, del T over del V, this one, del T over del V. I made a mistake. This is del T over del V. Okay, so this one. So del T over del V at constant S, this one, this term, and del P over del S at constant V, del P over del S at constant V. Now this one, this is V, right? Del V over del S at constant P, del V over del S at constant P equal to del T over del P at constant S. Similarly, del S over del P at constant T, del V over del T at constant T. Okay, just you need to note down this box PSTV in this order. Okay, PSTV. Then what you need to change position one forward. Okay, P position is here. That one forward means this P position will go here. Then S position here. This again now P position will be again forward means P. Then P will be here and then P will be here. Okay, so simple. Then what you need to do? Del P upon del T at constant P, down one. Del S over del V at constant P. Okay, this is the procedure. So you just need to note down this one box and PSTV. That's all. PSTV in this order. Okay, then you will change position P here. You will put P here, in second P here, and you will get all this. Okay, this is the trick, guys. Okay, I hope you have understood it. Okay, next. Next is Clausius Clapeyron equation. Okay, Clausius Clapeyron equation. Okay, Clausius Clapeyron equation. Okay, so this is Clausius Clapeyron equation. Okay, Clapeyron equation. Okay, so that is Clapeyron equation. Important one, guys. You will get many questions in your examination from this equation. Okay, so it's Clausius Clapeyron equation. Okay, Clausius Clapeyron equation. So this is, guys, this is dp upon dt equal to L upon T delta V. Okay, very important. So dp upon dt is equal to L upon T delta V, where L is latent heat. Okay, latent heat. P is pressure, T is temperature, and delta V is change in temperature. Okay, change in temperature. Very important formula. Okay, so here for if we talk about ideal gas, okay, for an ideal gas, for an ideal gas, for an ideal gas, for an ideal gas, PV equal to nRT, right? So from here, value of V is going to be for 1 mole of gas. Okay, we are going to take 1 mole of gas. PV equal to RT, N equal to 1. Okay, so V is going to be RT upon P. Okay, so now the Clausius Clapeyron equation is going to be dp upon dt equal to, this is L upon T into delta V. We'll put the value here. This is going to be L upon T into, in place of delta V we can write RT upon P. So dp upon dt is going to be PL upon T R T square R, right? T square R. So from here, this we can write dP upon P integration, that is going to be equal to integration PL upon T square dt, right? We'll integrate it. This is going to be ln P equal to minus P minus PL. So this is L, okay? A few P is here now. So minus L upon T minus L upon T minus L upon T plus ln P naught, we can say, right? Minus L upon T. Okay, we have integrated it. So and added one constant. So from here, this value is going to be ln P upon P naught by log property. This is going to be minus L upon RT. There is R as well, okay, RT minus L upon RT. So from here value of P is going to be P naught T to the power minus L upon RT for 1 mole of gas, okay? For an ideal gas, the pressure is going to be P equal to P naught T to the power minus L upon RT. P naught is the constant. Okay, so this is important. Now PT curve, that is phase transition curve, okay? Phase transition curve, phase transition curve, okay? Phase transition curve. So here for case 1 for water. If we talk about water, so this is going to be this Clausius Clapeyron equation is dP upon dt is for this L upon T into VL minus Vs. Vs is the volume of ice and VL is the volume of liquid, because ice, in this case, what is happening? Melting. Ice is melting, okay? Ice is melting. A water case. Ice is melting. So ice is melting. So it means this VL upon that Vs, right? So dP upon dt equal to L upon T into VL upon Vs. And here, guys, VL is less equal to Vs. The volume of this ice is greater than volume of liquid, okay? So in that case, dP upon dt is going to be negative, because this sign is negative. This is greater, right? Minus P. Okay, so this means slope of PT curve, okay? This is slope of PT curve, phase transition curve, slope of PT curve, okay? Next is, so this is the melting. Now boiling of water, now ice melts, becomes water, and then water boils, okay? So in that case, Clausius Clapeyron equation is going to be dP upon dt equal to L upon T into Vg minus VL. Vg is the volume of gas, because this will vaporize, right? And volume of vapor or gas is greater than VL, right? So this value is going to be dP upon dt, that is going to be plus V, means positive, okay? Now I'll make a curve, okay? So if you draw the curve P versus T, pressure versus temperature. Okay, this curve is going to be like this curve. Okay, this one. This is liquid. Okay, this is exactly. We'll make it again. Okay, this is P versus T. Okay, and this is like this graph, and this will go like this, and this is going to be like this. Okay, this one. So this is the fusion curve. Fusion curve. This is vaporization curve for water. Okay, vaporization curve. And this is gas sublimation curve. This is gas sublimation curve. Gas sublimation curve. Okay, this is liquid. This is solid ice, and this is gas. This part is gas. Okay, and this point is called triple point, guys. A triple point. Okay, triple point. This point is called triple point in phase transition, and this point is called critical point. Critical point. Okay, these are important things. This is PT curve, phase transition curve. Okay, okay. So now I'll talk about this triple point. Okay, triple point. Triple point. Okay, the point on PT graph. The point on PT graph. The point on PT curve or PT curve. Okay, point on PT curve. The point on PT curve where all the all the states all the state of water are in thermodynamic equilibrium. Okay, are in thermodynamic equilibrium. Okay, the points on RPT curve where all the states of water are in thermodynamic equilibrium. At this point, all the states, liquid, solid, and gas, are in thermal equilibrium, and this point is called critical point or the triple point. Okay. Next is, so all are in this thermodynamic equilibrium means this one. P1 at this point, P1 equal to P2, T1 equal to T2, and mu1 equal to mu2. That is thermodynamic potential for pressure and temperature. Okay. Next is critical point. Okay. Critical point. Critical point. Critical point means the last point on vaporization curve is called critical point. Okay. The last point, the last point on vaporization curve, the last point on vaporization curve. Okay, so the last point on vaporization curve is called critical point. This point is critical point, guys. Okay, this is the phase transition curve, and these are the states of liquid, gas, and this is the critical point. Okay, and this is, sorry, this is triple point, and this is critical point. My apology. Okay, so if you talk about the case 2, that is for carbon, case 2, that is CO2. If we talk about CO2, for CO2, dP upon dt, dP upon dt is going to be equal to L upon T into VL minus Vs. Okay, this is solid form, this is liquid form. Okay, for carbon, and in this case, this VL is greater than Vs, guys. So this term is going to be positive. And similarly, for boiling, this is for melting, and for boiling, if you talk about boiling, in that case, dP upon dt, that is going to be L upon into T into Vg minus VL, and obviously Vg is greater than VL, right? This is also positive. This is the positive, and this is the case of CO2. Okay, if you draw the curve for CO2, this is going to be like this. Okay, this is T, this is P, and this is going to be like this. Okay, this is solid, this is gas, and this is liquid. This is the CO2 curve, PT curve for CO2. Okay, and next is CO2. PT curve, PT curve for CO2. Okay, next is for critical point, guys. This you need to also know. For critical point, for critical point, del P over del V at constant temperature is going to be equal to del square P upon del T, del square P upon del V square, del square P upon del V square at constant temperature. Okay, this value is going to be 0. Okay, so for critical point, del P upon del V at T is going to be equal to 0, and del square P upon del square V at T equal to T is going to be equal to 0. Okay. Okay, well guys, so I'm going to stop here, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, and also guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, guys. So thank you so much. Bye now.